So we are looking at learning objective 18, which is to express numbers in scientific notation. I would have expected you to already know how to do this, but if you are a little confused or you want all of your notes, that type of thing, you can look at this. If not, you can skip this video, okay, if you don't want all of this information. So, rules for scientific notation. The decimal must be between the first and second significant figure. You should know how to count sig figs, so it's always between the first and second sig fig. Move the decimal left. We have a positive exponent. We add. So basically what this means is that we're moving from a big number to a small number, if that makes more sense to you. And then if we move the decimal to the right, we have a negative exponent, which means we subtract. And this basically the reason that it's a negative exponent is because we're moving from a small number to a big number. If you're multiplying scientific notation, you multiply the numbers that are in front of the times 10, and then you add exponents. And if you're dividing scientific notation, you are going to divide numbers, and then you are going to subtract exponents. That if you are multiplying and dividing, there is a button right here on the TI-84. So it's the EE button. So you are going to use the EE button whenever you do calculations with scientific notation. Now, most all calculators, so if you're using one of my calculators that is in my classroom, then you are still going to use the EE button. So it's the EE button that you use, okay? Don't plug in number times 10 raised to whatever power. That sometimes messes up your answer, okay? So let's look at a few examples. So in this example right here, okay, I know like if I'm looking at this, the decimal point is not present. So I'm going to go into the number until I hit a non-zero, and those are significant, right? So this is my first significant figure that I hit. Now, my decimal point needs to be in between the first and second significant figure. So I'm going to be 6.79 times 10. And then I'm going to raise it to a power. So however many places I move, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, I moved that way, so I moved to the left. So it's a positive 9. So 9 meters. Okay. So then I have this one, this next one. Again, the decimal point's present, so I'm going to go into the number until I hit a non-zero. Here's my non-zero. So this is my first significant figure, which means that my decimal point needs to go between the first and second non-zero number or significant figure. So 9.78 times 10. And then I'm going to move the decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm moving it 9 places to the right. So then this is a negative 9 because I have to have a negative exponent there. And then meters goes on the end. So your unit always goes on the end. So then if I'm looking at these two, then form for my scientific notation. So I have wrong form for my scientific notation. Now, again, this decimal point needs to be between the first and second significant figure. So then 3.79 times 10. Now I moved it 1 place to the left. So that means I add 1 exponent. So instead of it being negative 9, so negative 9 plus 1 should be -8. So -8 would be my exponent here. And this is second. Needs to be between the 4 and the 9, right? So I need to move that decimal point over 2 places. And now I'm moving it this way. So then if I'm moving it to the left, I'm going to subtract. So subtract 2. So then 4.97 times 10 to the -10 seconds. And that is scientific notation.